cluster kind of thing. That's another kind of out there and a hyper example.
A real common thing now is nodes with different data densities, right? I added so-and-so nodes that had data densities of maybe 20, 30 terabytes per node. Maybe I go and add another set of nodes that have maybe 100 terabytes of data density. That is far less performing than the initial nodes that I added, right? So there's a lot more flexibility and granular control over the performance or the data access, etc.
Yarn's been a nice advancement towards doing some things. Yarn was, Mapr was, to be honest, right, Mapr didn't jump into the Yarn thing. Our customers weren't asking for it. Of course, the reason our customers weren't asking for it was because they didn't need to. We already had great resource control and to be able to do all the things we talked about for a multi-tenant environment. So a lot of the issues that Yarn solved, we'd already solved. But of course, we provide options. We provide everything in the open source community. We want to support everything in the open source community because we are full distribution of Hadoop. So we're running on Hadoop 2.4.1 now, which is we have Yarn features. So this is the kind of the features for a lot of the Yarn that exist. This is probably a couple of months old, so it can be a little bit outdated. But this is what Mapr supports from a resource constraint because of all the things that we can do. Right, we can isolate disk I/O. We can make sure the data is moved to a particular location. Now here's the cool thing: we can support. Once again, this was there because it was required by the businesses that we do business with, right? They've been doing it for a while. If you're just coming into Hadoop, you're probably going to go with MRV2, which is this Yarn guy, right? Because it's the newest, and you're going to go with that. If you've been doing this for a while, you've probably got applications that are running MRV1. So we have to be able to run MRV1 and MRV2 in the same cluster on any node at any time, because they don't want to move everything they've got over here to this new flavor just yet. Right? They want to be able to use this, but take advantage of the new stuff as it comes out and build new projects on that. So we have to support both those aspects of it.
Are they backward compatible?
What's it again?
MRV1 and MRV2. MRV1 and MRV2, are they backward compatible at all?
Backward compatible to?
The way you said it, it looks like you have
yes,
to
it
run
is.
them parallelly, which means it has to be separate. You can't mix and match, right? So
no, you can. I can run. Well, so for instance, there are certain aspects depending on the job that you have in the version of MRV1, right? I can take that job like let's take an example of a word count. I can fire up a word count on Hadoop 1 or Hadoop 2. I can fire it off the job tracker or resource manager, right? Some of the older applications don't have that because there was no concept of Yarn. It won't interact with it in that way. And they don't want to have to upgrade it to the newer aspects of it. So they want to run on the legacy MRV1 that doesn't know anything about Yarn and operate in that fashion and not change anything about it. Are there no constraints? Is it perfect across the board? I don't know anyone's going to say that. But in many cases, right, the key here is to be able to set like existing Hive jobs. I want all my existing Hive jobs to run because it's Hive 11, and I want Hive 11 to run in MRV1, while my Hive 13 is running over here, or my Hive with Tez is running on Yarn, right? So.
And I just say, no, they're not. That's why we support both of them in the same cluster. So if you have projects that are written for MRV2, you will not be able to run in other distributions. You won't be able to run that in side by side to projects that run on MRV1. So the main takeaway there is that within the Mapr cluster, we provide the ability to run either version and on the same node.
So within the node, can it differ, or the node can only stick with one particular?
No, you can run. I can fire off a MRV1 and a Yarn job at the same time on the same
node. Okay.
It's pretty cool.
Yeah, very important for small clusters, test clusters, etc.
Well, as I said, if you're just coming into this and you don't have any legacy, well then you don't care.
And you say that that's your distribution does it, but not the others.
At the same time, on the same node, there's other ones that's one or the other. The other ones it's this node can be one and this node can be the other.
Can Mapr do it, or can other Apache distributions do it?
Once again, right? It may change, right? Everybody advances constantly, but the last time I looked at it was October timeframe. It was either cluster-wide on one, and the other one was it was node dependent. So this node was going to run MRV1, and this node was going to run this node's running Yarn, this node's running MapReduce, MRV1. Am I wrong? Feel free to jump in and tell me I'm wrong, because it's okay. I've been wrong plenty of times. They're all good distributions. Don't get me wrong. Yeah.
When somebody talks about Hadoop, actually, two things that come into my mind is see that you guys are moving away from HDFS. Was there a particular reason or some kind of limitation that made you, or from your experience, because I'm not understanding, what is the benefit that you guys are getting? by not-
All this presentation so far was why Mapr.
Well, I know, but the thing is, what I'm trying to understand is, I know it's an open source community and everybody's going in that route.
No.
They are not open source, you read it, right?
Well,
Our file system in and of itself is an intellectual property innovation, right? If we lay down project by project and line by line, I mean, we commit to every open resource, we commit to bugs, all that kind of stuff. Our file system is free for the most part, except for some of the high availability, some of the disaster recovery, some of those type of feature sets that we were talking about, right? But for the most part, the difference is, the reason we went down this route is, one, it's more resilient. So for example, that 1,400 node cluster, everything running in one, has had 99.99% reliability from a standpoint of even doing upgrades. I don't have to take the services down to upgrade from one version to the other, right? I can upgrade portions of my cluster at one point for one project and upgrade a different portion of a different cluster for another project. But being able to control that, control resources, control how things are consumed, right? I can't do that. I can't say to HDFS, only put this data on these 3 nodes and only put this other data on these other 3 nodes over there. It gets pushed everywhere.
let me take a stab at that too, just from another point of view, because I think it's a real good question. So here's the deal. Our founder, MC Shrivas, spent his time at Google, working on Big Table, at Spinnaker on global namespace, etc. Right, a lot of storage experience. He looks at Hadoop and says, you know, given his vision of knowing so much about storage, wow, this HDFS, look at all the things it doesn't do. It doesn't do the HA. It does not do the granular volume control. It doesn't do snapshotting and mirroring. There's a bunch of layered feature sets that we describe that as making enterprise grade. And if anybody's trying to use Hadoop to come in and replace enterprise components, those are the components that you probably have to have in order to make that substitution. Otherwise, it's kind of a playpen, it's kind of a test area, etc. So I think the founder, MC Shrivas of Mapr, one of the founders, saw a limitation to HDFS and what it was written for, and said, I can make that better. And then in order to provide the compatibility, it's fully HDFS API compliant. So anything that makes a call to HDFS will work with Mapr and Volume.
HDFS, Hadoop in general, is designed to have an extrapolated file system. How many file systems are there for Hadoop? I mean, there's a local, right? There's the distributed, right? There's some other memory web-based aspects. So it's designed to be able to do that aspect of it. And there's several differentiations. First off, when it first came out, it was much slower. It's gotten better, right? It's gotten much faster than it was 2 years ago, 3 years ago. But when it first came out, right, so we ditched the Java aspect of it. We format the file system. We format the partitions on the disk so we know what's happening around that guard. So when it comes to failures and issues, there's no coordination with the name node, right? It's mathematically in the algorithmic control of the file system to make decisions, move things, get things operational, so that if you have issues, the data's moved out quickly, much faster than any other systems to get your protection back up. And if the system crashes, if you take the whole thing and reboot it, I can get back up in minutes. In just a minute, take from nothing, everything's turned off, to coming up and being up in minutes.
Now the other question is, now that you don't have the concept of lean node, would that add more processing power? Or actually, would that mean that I would probably not stick with the so-called commodity servers because I'm adding more processing to each node?
As I said, generally speaking, it takes less hardware to get this job done than, so I need less aspect of.
When you said less hardware, you're still talking about commodity.
Yes, commodity hardware.
Commodity or whatever you want.
Yeah.
Whatever the reference
Because
architecture
when
is.
you say I'm going away from so-called, I just was wondering if it's not regular, hey, I'm just going to pick a cheap box. And, you know,
Yeah, you can. I
still do that.
got an old Dell. I got a 6-year-old Dell PowerX that's barely 64-bit compliant. That runs 3 nodes, sitting in my house with 10 gigs of RAM. So it runs virtual. It's a virtual, VMware running 3 nodes. Each node has 4.5 gigs of RAM on it for each of my virtual nodes, and it's 10 gig total for the operating system. It works for what I need to for playing in my house anyway. I don't want to spend too much time over here. We want to get through a couple other things here, especially talk about some of the aspects of advancement in SQL and kind of what's going on from a person or from an engineer or a data wrangler or a data scientist digging into data. But once again, to recap, multi-tenancy is an important aspect of it. Very successful. Many, 500 plus customers, multiple projects, all in the same cluster. The only time I end up with multiple clusters is because someone wants to spin a development cluster off in a completely separate, isolated aspect of it. But going from cloud to local or local to cloud. So Climate Corporation is a great customer of ours, and they deal all their data for climate and climate change and what's going on with climate and checking things for farmers and so they can plant and get and grow better crops. All that data sits in Amazon. Their development cluster sits in-house, and then as they get their project and they want to run it up and run the actual test on the massive amounts of data, it scales up into the cloud, automatically builds out, throws the servers up there, and they finish their 14-hour test of whatever they were looking for and pull all that back for analysis inside. So scaling, moving around, going from cloud, whatever. A lot of our customers do it in both directions. Resiliency, of course, 99.999% uptime, right, with zero administration and no data loss, right? So that's the goal. That's what we do. That's what we try to deliver. The performance and scalability, of course, is normally 2 to 5 times faster, 30 to 50% reduction in hardware. Interoperability, this is a key aspect of it. I haven't gone into a lot of it, but since it's a read-write file system, it's a real file system, I can natively mount NFS on my nodes. And this is like taking an R script. I got an R script that doesn't know anything about Hadoop, and being able to take that R script and package it in such a way that I can use Hadoop streaming to have it go out and actually interact with all my data and process and do some machine learning without having to change it at all, means that a lot of times when customers come into play, they can start learning and using Hadoop without having to change it and add a lot of skill set, a lot of challenge. So I don't have to use some of the Hadoop commands to access data. I can just do it like I'm sitting at my Mac here or my Windows box. I can mount it up, I can clean data, I can edit it, I can copy it into the cluster and then say, oh, it's got a tab, it doesn't belong here, and just edit that across, run an edit command to clean everything in that directory in my cluster without moving the data out and back in. If you haven't dealt with Hadoop, that is especially when you're first getting started, that's a bit of a challenge to kind of work out the workflow around that. But just being able to take a look at my data, edit it where it sits, and not have to move it anywhere is a pretty nice thing to be able to do from an interoperability perspective. There's a lot more to speak about being able to work with different legacy pieces of gear because of that. As an example, interoperable, like HP Vertica. They get that awesome, very expensive, but cool database aspect that they use. When it runs on Mapr, they don't even know they're running on Hadoop. Because according to, it looks just like it's on NFS mounts, the way the data copies around. I'm not going to a while on that particular architecture, but it's one of the things that allows them to go and take it and deploy that on Mapr in a matter of minutes, as opposed to trying to figure out how to get it to work with every aspect of Hadoop. Now, it also has the connectors to work with the HDFS connectors as well, but it can also just work natively from a standpoint of just sticking the code on Mapr Enterprise. HA, we talked a lot about HA. There's a lot of HA concepts. Not all HA is created equal. There's a lot of differences, but the way I like to say it simply is if I'm running a MapReduce job, right, and it's 4 hours into it, and I got 4 hours more to go before it gets done processing its data, and I just reboot the whole cluster. Reboots, a couple of minutes, cluster's back up, picks up where it left off, and it goes and finishes the job. So being able to actually, and that's applied, not every component is applied that same level of aspect, but for the most part, most of the things that you throw in it from a ecosystem component structure, putting it on top of our system, when it boots back up again, it picks up where it left off and it finishes the job. So that is an example of just total overkill HA. From a standpoint of being able to recover and pick up. But generally speaking, the whole point there is, like I said, 99.99% reliability, instant recovery. The rolling upgrades is nice because, once again, if I've got 40 different components out there running, getting everybody in the planet to upgrade at the same time and go from Hive 12 to Hive 13, it's not as easy as you want. I think in 14 different development teams to all agree to that. This weekend we're going to do that. So being able to say, all right, you guys are this weekend, you guys are next weekend, you guys are the weekend after that, being able to pick and choose how we're going to do that from a business unit perspective, from a development cycle perspective, and reside the data in one cluster so I can take advantage of being able to provide that information to everybody. It's been beneficial to a lot of the people that use it. We're gonna talk a little bit about SQL. We're gonna take a look at it. So you heard a little bit about these SQLs here, right? So all of these SQL aspects of it all run on a Mapr distribution of Hadoop. We got Apache Drill. We're going to talk about. We got some labs set up. We can go through and do later on for some hands-on. I've got some sandboxes up here we can pass around to make sure everybody's got a copy of it. So here it is. Hive with Tez, right? So you can run Hive with Tez. You can run Impala. You can run Presto, which is I think was that the Facebook Presto. Spark SQL and HP, as I said, HP Vertical. So all of those things can run. Actually, you can run all of those things at the same time in the same cluster if you wanted to. As I talked about those different types of upgrades, being able to support a complex environment with customers that are at different levels in their different projects as they exist going forward. You may not have legacy in your environment yet, but eventually, when you're successful with Hadoop, when you're making money and you're making a competitive advantage, and it's happening, a year from now, you're going to have legacy stuff you have to support. And being able to support multiple versions of different types of components all in the same ecosystem is something that they come to us for, because that's our commitment, right? We support multiple versions so that you can have the time to migrate and change and affect changes in your data warehouse according to your business, and not have to change everything and make it work according to Hadoop. These are some example use cases we did for a Department of Transportation in a state recently, right? This is all the things that kind of ran in one cluster, right? We had some streaming, we had some batch jobs, we had some analytics, we had some GIS stuff going on. So one of the aspects was pulling some things off, doing some mainframe offload, pulling the data off, doing some batch on that, or aspects of it, because the data is not used that often. They don't want to keep it on there. It's expensive on Psycho, so we want to pull it off, and we want to. And this use case is not only to Mapr, but I would say only an interesting thing to Mapr is being able to do all this in one cluster. But any of these types of use cases can be done on any of the distributions. So pulling off the mainframe aspect of it and accessing it, pulling off PeopleSoft so they can do different types of things, analytics around what was going on with the workflows and maintenance schedules, relational databases, being able to do scoop, pull in some things, feed it back into the relational database so they can feed back to their reporting models and things like that. So pull off some things and push it back into it to be able to offload some of the work, but continue to feed the existing reporting methodologies that they existed with. Flat document searches. Many, as you can tell with something like this, they had lots and lots and lots of documents, and they didn't know where it came from and whose copy was where. So being able to pull all the documents into one location and making sure that all the people that were using document stores were now using NFS mounts off the cluster, and they just started keeping all their documents in the cluster for each laptop, each person, each work group. And then allowed them to be able to search and look at all those documents, say these are duplicates, this one was built on that one, which was built on this one, which was built on this one over here, so this is the only one we want to keep, all the other ones go away. That kind of thing allowed them to clean up a lot of their document issues where they didn't trust any of their reports, right? I don't know who built it, where it came from, where this, so everyone was doing their own thing. So they're trying to bring all these people where all they're saving all their stuff to one location they could actually do analytics around was a pretty big thing for them. Sensors, of course, pulling in sensors from different types of stations, road sensors, water flow sensors, toll road sensors, all that kind of stuff, right? Pulling all that in. And then geospatial data. The first thing here, I mean, this is a work in progress. We pulled in, did some Esri tools with them so they can use that. Esri has some nice tools that work inside of Hadoop, so it's not officially listed in our support, but we pulled those in for Apache, for Hadoop, and pulled them in, and they were using that. Also being able to just, once again, land that in the document stores they're used to, and being able to access that data just like they would, but now it's all in one location, allows them to search it and look at what's going on with their geospatial data. But what we wanted to talk about was drill. We're going to talk about that later today as we get into some hands-on aspect of it. Some of the things that are going on with drill in general that are difficult is we talked about all these different types of data sets, but what we want to cover later today when we dig into it with Hive, when we're talking about Hive, when we're talking about Impala, when we're talking about touching drill and actually doing something, it's the question of how long does it take to go through this to get an answer that's worth anything, right? How many times do you have to go through and say, nope, useless, go back again, useless, go back again. Well, the aspect of drill is being able to sit down and do that without having to go talk to my IT guy, my database administrator, sit down, what's the data, let's look at it, let's build a schema, let's build it all together. Nope, go back, you start over. That's another month I just lost, I got to start over again. So how do we short circuit that process to get it down to one or two guys able to touch, analyze, dig into the data, figure out what it looks like, yes, this is what I want to do. Then we go to the IT and the database administration, everybody else, and say, now how do we move it to production to meet our SLAs, right? That's what we're going to talk a little bit, or hopefully touch on a little bit as we talk about some aspects of drill. I got a lot of other slides here, but time's running out. I want to get a couple of questions. These are all drill slides that we'll talk about later. Woohoo! Go. And so, further reading on drill, we'll talk a little bit later. But further reading from Mapr, right? We do have some free, awesome Hadoop Essentials. You can go down and join and take some online classes and look at that aspect of it. We got the answers at mapr.com where you can ask all kinds of questions and the private community to respond to you. And of course, you can download the immediate edition. I've got some sandboxes up here with drill 5 connection base already loaded on it with Yarn and MapReduce 1. You can take a look at some of those. And so the community edition is free for anyone to use. Is there any questions I can ask that I've done bloviating for an hour and you're all dying to get to lunch?
So I listen to this. Does this have the ability to replace your transactional processing? I mean, I guess one of the things I'm sitting here thinking about, maybe it's because I come to the side of this from a database admin perspective, and I'm just sitting here going, so yes, I see the operation, I can see the OS side of this, I can see the hardware side of it, I can see the data warehouse, and I'm like, okay, so how does this fit into all of those? Are you telling me that I can run my business off of this?
Yeah, I mean, there's certain aspects of it that, this is not going to replace your DB2 or your Oracle for certain things, right? Right? There's no ACID level compliance around certain aspects, right? I don't have an ACID certification. So there's certain things that it's not the answer to all things on the planet. But like a Rubicon, if you're familiar with Rubicon, Rubicon project, they're a giant ad marketing guy. So when you show up at, you do a search on Google for new lawnmowers, and you go to the next you go along into Facebook, and you get ads for new lawnmowers sitting there for you. Rubicon project, you can thank those guys for that aspect of it. But so what they do more transactions a day than Google. They do billions of records a day and looking at and evaluating where these spots are for advertising, who's the target audience, and then selling that in an auction to the people to buy that aspect of it, to put that ad in front of you because it's because you're the one who's looking for lawnmowers, right? So that's what they do. They use the Mapr database edition and the Mapr distribution. And actually, I can point you to a link from Strata in San Jose this couple of months ago that goes through the actual Rubicon project administrator actually goes through and talks about why he was at one distribution and why he went to another and what benefit that gave him in his company as he made that choice. And this is Jan Gelder, I think is his name, or Jan, I can't remember his last name, but he was at Yahoo for several years, ran a lot of their Hadoop clusters before he got pulled over to do the Rubicon project, and he knows what he's talking about. But they run the core of their business. Anybody familiar with Beats Music? Right? The Beats has this cool music service, right?
Apple just acquired them.
All that information about how they decide what song to offer you, that's all on Mapr. So that less than 200 millisecond response time to figure out what type of thing you want to listen to because you're listening to this song and other songs you listen to. That's a Mapr response to that aspect of it.
In other words, it's just not going to replace your transaction systems. Okay?
No, it's not.
Your accounting, your ordering, your inventory, order systems, they're all transactional.
They're the only ecosystem guy out there says he can do that. Well, I don't think they can yet, but they're getting there. From a Hadoop perspective, Splice Machine is talking about doing that kind of stuff. I don't think they're quite there yet, but they're a little startup company. I know they've got an office I go up to regularly in St. Louis, but they're talking about doing that level of kind of transaction in Hadoop. But
okay, I mean, I guess I can see. Could you use this then to validate credit checks and stuff like that to score customers and see whether or not it's even worth it to lend them data?
Yeah. Absolutely.
Yeah. For that example, you can implement that in the way you wanted it, right? And then traditional developers would implement it in the way that you were saying it, right?
Yeah.
So that's where the industry is moving towards, right? So it's when the developers move along to say, hey, I want to do the distributed computing because even my cell phone now here has got a multi-threaded, multi-core, right? So when you want to take advantage of the hardware, when the development mindset shifts towards that industry, the traditional way of looking at it, can I do it in this way? Transaction will slowly move there.
What you're basically doing is a read-only system. Mapr has some rights, but the whole idea of the distributed query is initially you have massive amounts of data. You want to correlate it, aggregate it, and information from it. You're reading it, there's no transactions associated with reading it.
But some of the aspects that make it easier for us to do closer to what you're talking is because it's read-write. I can actually go in and edit files. I don't have to, pull it out, edit it over here, put it back in. I don't delete it and put another copy of it in there. I can edit a file. I can bring up a cluster, open a file, and start typing. And as I type the words, they show up. I start doing word count, and they show up.
Yeah, it moves very rapidly. So the question was asked about real-time analytics as well. There's amazing advancements to move out of the batch mode into the interactive mode and then into the real-time processing. Right? Credit card fraud transactions are processed real-time.
And there's a lot of distributions do these kind of things for a lot of different aspects. But yeah.
Well, but from what I gathered from your presentation, one of your strongest points, I think, from my understanding, you say that you take much less hardware. So
a measurable amount, yes.
So there's a cost, even with cheap commodity processors.
Absolutely.
There's a cost difference between 10,000 processors and 2,000 processors.
Yeah, fully burdened cost, right? When you're talking about how many people it takes to run it, your air handlers, your power, your different CPUs, the upgrade process, how long all that come into plays where, it's definitely where my value and my aspect of it that I deliver on a regular basis to production customers. Getting off the ground in a science project, we have a lot of those features are available in the community edition, so I should take a look at it. We support more of the open source community, so if you want to take a look at some HiveTez and some Accumulo and Accumulo is everybody, but HiveTez and Impala and Drill and Shark all on the same cluster while you're looking at it, you can do that, right? So, because I talked a little bit about our intellectual property. I talked a little bit about our value, where we're at. This is what that extends up to these things as we deploy those in our data platform, right, in your data center. But so we support more of the open source community. We contribute to all of them, and because it's our job, it's our goal to make sure you have a resilient, deployable system that supports everything you need to do with options to change, to take advantage of the new open source things that come out, without having to worry about Hadoop, so that you can focus on the business flows that are being used by these open source projects to solve your issues, and not worry about the underlying architecture of what Hadoop's going to do. That's it. I forgot to hand these out. Somebody asked questions. Who asked a question? You asked a question?
Right here.
Oh, you might get somebody said.
Yeah.
All right,
And then I just have a few logistics things. There's a lot of guys in here. There's more than one bathroom in the building. So there's bathrooms on every floor. You may have to step.
Can't get to.
Well, you can go on every floor too, but there's yeah. So you can go to the bathroom on 5, 4, 3, 2, or 1, just so you guys can spread out. Okay, we're a little bit behind. We're about 30 minutes behind, so we're gonna attempt to catch up. And the way we're gonna do this is we're not gonna have a lot of time